Yes, Alvina is there, Arya is there, Afnan is there. Okay, let's start. In our in your previous class also you have seen this chapter triangles, and there we were talking about the congruency of triangles. We were checking whether two triangles are congruent or not, and we understand the meaning of congruent, right Arya?
Yes, mom.
Please tell what is the meaning of congruent figure.
Like equal, like when we put it on top of each other, they will be equal in size or angle.
Yes, when we are talking about congruent shape, that means we are talking about two such shape which are exactly same in shape and size. Two figure which are exactly same in shape and size, that's called congruent figure. Okay, just yeah. So two such figure which are exactly same. Suppose I am drawing a triangle and I am drawing another triangle. If it is exactly same in shape and size, shape is same, both are triangle, and size has to be same. If this is 3 centimeter, this is 4, this is 5. So here also one of them has to be 3, another has to be 4, another has to be 5. Then we will say both are congruent figure. Okay, now, or congruent shape. Here we are, apart from congruency, here we are having the concept of similarity also, similar shapes. So what is the difference between congruent shape and similar shape? Similar shape means, suppose I am drawing a circle and I am drawing one more circle. These two are similar shape. Okay, these two are similar shape. One can be bigger, another can be smaller, doesn't matter. But for the congruency, we used to check whether both are covering each other completely or not. The way my one of the palm is completely covering the another palm, these two are congruent with each other. Why? Because you can see it is covering each other completely. Okay, it is exactly same shape and size. That's called congruent figure. And similar shape means, we can see on the screen, one of the circle we are having the bigger circle, one is the smaller, still we are calling them a similar shapes. Okay, so this is the difference between congruency and similarity. If we are having an equilateral triangle, suppose we are having a rectangle and we are having one more rectangle. Now the question is, both are similar or not? We will check that. Okay, circle was similar, the bigger circle, the smaller circle, all the circles are similar with each other. All the circle, whatever circle you are going to draw, be by taking a radius of 3 centimeter, by taking a radius of 5 centimeter, by taking a radius of 10 centimeter, by taking any radius, whatever two circles you will draw, that will be similar figure. So when we are talking about similarity, we have to check both the figure are same or not. Circle with circle, rectangle with rectangle, square with square. So suppose I am having a square. This is square and this is square. These two are similar shapes. The first is square and the second is square. These two are similar shapes. Okay. So similarity means the shapes, only the shape has to be same. The measurement, the side of this square is 5 centimeter, 5 centimeter, 5 centimeter, and 5 centimeter. And the side of this one is 2 centimeter, 2 centimeter, 2 centimeter, and 2 centimeter. So you can understand the size doesn't matter. When we are talking about similar shape, one can be bigger, another can be smaller, but there is very important criteria. That is, all the side has to be in proportion with each other. Okay, that means A, B, C, D. Here, if we are calling P, Q, R, S, can you see side AB and PQ? If we will compare, then there is a reduction of 3 centimeter. Can you see? In the other side also BC and QR, there is a reduction of same 3 centimeter. In the other side CD and SR, there is a reduction of same 3 centimeter. In the other side AD and PS, if we are comparing, can you see there is just a reduction of the same 3 centimeter? Can you see it? If that is the case, then only we will say it's a similar figure. So to be a similar figure, there are two criteria. What are the two criteria? All the angles has to be same. Since I am talking about a square and a square, so angle, all the angle will be 90 degree. That is known to us. Any square, teeny tiny square or huge square, the internal angle, the one of like any angle will be 90 degree only, right? Yes or no? Yes or no?
Yes, ma'am.
Okay. When we are talking about, yeah, the sides has to be in proportion with each other. What is the meaning of proportion? The meaning of proportion is, here I was showing you that all are just reduced by the same. So we will not be taking what is the reduction. We will see whether all are in proportion or not. Now this proportion word, have you heard in while baking a cake, have you heard that the proportion needs to be very accurate, then only we will be able to bake a cake. When you will go and find a recipe on the Google, there will be recipe like that: 200 grams of flour, then maybe 100 grams of sugar. So the proportions are given over there. What is the meaning of proportions? That means ratio is given over there. Okay, so here also, when we are talking about the similar figure, the ratio between the sides has to be same. What is the meaning of that? The meaning of that is AB by PQ is what? AB is 5 centimeter, PQ is 2 centimeter. Now check BC by QR. Is it also 5 by 2? Is it also 5 by 2? Now check CD by SR. This is also 5 by 2. This is also 5 by 2. Check AD by PS. This is also 5 by 2. If all are same fraction, then we will say that both the figures are similar figure. That means you must have understood now that if we are reducing, we have to reduce in a certain proportion. Okay, suppose we are having a rectangle where the length of the rectangle is 8 centimeter and breadth of the rectangle is 6 centimeter. Suppose we are having another rectangle. Here the length of the rectangle is 4 centimeter and breadth of the rectangle is 3 centimeter. We will be checking whether the sides are in proportion or not. What is the meaning of proportion? Can you see 8 became half? That is 4. Can you see 6, the other side, breadth became half? That is 3. That's the meaning of proportion. So if we are reducing the length by half, the breadth also we must reduce by half only. That then only we will be able to say that the figure ABCD both are similar figure. So there are two criteria. The angle has to be same, all the internal angle, all this angle has to be same, and also the sides has to be in proportion. Again, let's check the side whether it is in proportion or not. Proportion means the ratio between all the sides. Like AB by PQ is what? 8 by 4. That means 2 by 1. Okay. What about BC by QR? BC is 6, QR is 3. Can you see? Again, we got 2 by 1. What about CD by SR? Can you tell me what will be CD by SR? Anyone? Anyone? What is CD? What is CD? What is CD? We are talking about a rectangle. So do I need to write CD? A rectangle. Do I need to write CD? If ABCD is a rectangle, what will be the length of CD? Can you see my screen? Can you see my screen?
Yes, ma'am.
Turn on your camera, everyone. Turn on your camera, please. Arya, Noah,
Yes, ma'am.
Alvina, Sumaya, Afnan. Please turn on
Ma'am, I already said you last class.
your camera is not working, Arya?
Let me try again.
Afnan?
Can you see?
Noah? Sumaya? Alvina? Are you understanding what we are talking about? What is the length of CD over here? If I am drawing a rectangle ABCD where AB is 8 centimeter, BC is 6 centimeter, what will be CD? Don't know? It's a rectangle. Again and again, I am just pointing that it's a rectangle. What will be CD? Seriously?
8 centimeters. Ma'am, 8 centimeters.
Exactly. Why so confusion?
AD is 6 centimeters.
Exactly, Afnan. AD is 6 centimeter and CD is 8 centimeter. Why so much of confusion? If ABCD is a rectangle, AB is 8 centimeter, BC is 6 centimeter, CD will be what? It will also be 8 centimeter, no? Because we are having, this is just the opposite side. Length in a rectangle, only two measurement we are having, length and breadth. So if length is given, breadth is given, even if it is not written in all the sides, okay, beside all the side, even if it is not written, I am drawing a rectangle. A, B, C, D. I am saying AB is 8 centimeter. BC is 6 centimeter. I was just asking a simple question. What will be the length of CD if ABCD is a rectangle? Is there any confusion to anyone? Sumaya, Alvina, Noah, Arya, Afnan has already answered.
No, ma'am.
This will also be 8 centimeter. This will also be 6 centimeter. Yes or no?
Yes, ma'am.
Okay. So let me summarize everything. Okay. When we were talking about this math chapter, we have just started triangles. Okay, let's start from the very beginning. Okay, because it's just few minutes we have started. Let's start from the very beginning. Triangles we have started. Who asked? Sumaya asked. Yeah. Rest of the student, yes, we have started triangles. And in the very beginning of the class, I said to everyone that we are going to start triangle because in Arya's exam, triangle chapter will be there. Okay. In your upcoming exam, if any other chapter is going to come, please let me know. I will, after finishing this one, I will pick that chapter. Okay. So, anyone joined just now? Sumaya, no, 2 times it's showing your name. So we have started triangles over here. Now I was telling you what is the concept of congruency of triangle. Congruency of triangle, that means two shapes which are exactly same in shape and size. For example, if I am having one of the page and then another page, these two are congruent figure. Why? Because this page is going to cover the other one completely. You will be able to say both are covering each other completely. That means both are exactly same shape, and the measurement is also same. Then only both are covering each other completely. That's the meaning of congruency. Exactly same in shape and size. And this chapter was there in your previous class. Okay, I can show you my palm, one of the palm and the other palm. These two are covering each other completely. And that's why we will be saying that both are congruent to each other. Okay, that's the meaning of congruency. This concept you have learned in the previous class. Here we are going to talk about similar figure. There we have talked about congruent figure, congruent shapes, congruent triangles. Okay, specifically triangles we have learned over there. Here we will be able to first understand about what is similar shapes. Similar shape. Now I am saying that two shapes are similar. Like one of the example is a big circle I am drawing, and then I am drawing a smaller circle. And I am saying that these two shapes are similar to each other. Why similar? Because there is a criteria to be a similar shape. That means the radius or the diameter of this circle we are reducing by half, reducing by double, like increasing by double, increasing by like 3 times, or maybe reducing by 1/3. If this is how we are reducing each and every measurement for the circle, how many measurement is there? Only radius is there. So here only radius is there. So we are reducing the radius by half, or suppose the bigger circle is having the radius 8 centimeter. The smaller circle is having the radius as, let's say, 4 centimeter. So we are reducing the radius by half, and then we are getting the other circle. And these two shapes are similar shape. Okay. Similarly, if I am drawing a square and I am drawing another square, these two shapes are also similar shapes. So are we going to call all the shapes, one is bigger, another is smaller, as a similar shape? Like the size variation is allowed, only the same shapes it has to be there, only circle with circle, square with square, rectangle with rectangle. Okay, triangle with triangle, bigger is smaller doesn't matter for similar shape. Yes, bigger is smaller doesn't matter for similar shape. The name is similar, it doesn't have to be exactly same measurement. It doesn't have to be exactly same measurement. In congruent it has to be exactly same measurement, but for similar shape it doesn't have to be exactly same measurement. Listen to me carefully. I am saying that the shapes has to be same. You can only compare a circle with another circle, and then you can say both are similar or not. You can only compare a square with a square, and then you can say both are similar or not. You cannot compare a rectangle with a triangle. This is completely incorrect. This is not we are going to discuss. We are not going to discuss over here. This is not similar shapes. Okay, but when you are going to compare a circle with circle, or maybe a square with a square, a rectangle with rectangle, so anything like bigger is smaller doesn't matter. Anyway, you can take the side. No, we cannot take the side anyway. There has to be proportion. Suppose you are, that's what I I was showing you. AB, okay, P, Q, R, S. One is smaller, another is bigger. Doesn't matter. When it will be similar, there is a criteria. What is that criteria? The criteria, the first criteria, that all the angle has to be same. All angles, internal angles has to be same. So here we know when we are talking about square ABCD, this angle is 90, this angle is 90, this angle is 90, and this angle is 90. When we are talking about square PQRS, we know this angle has to be 90. This is 90, this is 90, and this is 90. We have learned in the chapter quadrilateral that a square is having all the angle of square, each angle of square are of 90 degree. Okay, and for rectangle also each angle are 90 degree only. We know that already. So both the square are having all the angles same. There is one more criteria, that sides must be in proportion. Sides must be in proportion. What is the meaning of that? The meaning of that means the ratio between side AB and PQ. The ratio between side AB and PQ. If you have learned the third chapter, that is pair of linear equation in two variable, there we used to check A1 by A2 ratio, B1 by B2 ratio, C1 by C2 ratio, and we used to check all are same, all are different or what. Here also we are going to check the ratio. Okay, the ratio between what? The ratio between AB and PQ. Here also we will be checking the ratio between consecutive corresponding sides. That is AB by PQ we will be checking. What is that? Then we will be checking BC by QR. What is that? Then we will be checking CD by RS. What is that? And then we will be checking AD by PS. What is that? If all are same, if all the ratio are same, 1 by 2, 1 by 2, 1 by 2, 1 by 2, if all the ratio are same, then and only then we will be saying that these two figure are similar figure. So side doesn't matter, but the sides has to be in proportion with each other. It is not that you are decreasing one of the side by half and the other side you are just decreasing by 1/4. If that is the case, then it is not similar figure. There are two most important criteria to be a similar shapes. You cannot say any two shape as a similar shape. You cannot say any two shapes as a similar shape. Suppose I am drawing a triangle and I am drawing a teeny tiny triangle. These two are similar. We don't know. Okay, we don't know. It is not necessary that these two are similar. We need to check the angles. Each and every angles of the bigger triangle is same as each and every angle of this smaller triangle. Is that even possible? Yes, it's that, like, it's possible, because angle sum property says that sum of all the angle here will be 180, and angle sum property says sum of all the angle over here will also be 180. So the angle has to be same. Few cases we will see that where angles are same, and few cases we will see that their angles are not same. It can be like this: here 60 degree, here 30 degree, here let me take 70. Wait, 180, no, 70, 80, 90, 100, and then 80. This is 80. This is how we can take the angle. Here angles can be like this. This is 30, this is 70, this is 80. Angles can be like this. This is 70 I have written. If it is not making sense to you, I have 70 written over there. Okay, so if this is how you are having the angle, like one of the angle over here is same as one of the angle over there, then another angle over here is same as another angle over there, then the third angle over here is same as the third angle over there. If that is the case, and also the sides are in proportion with each other, sides are in proportion with each other. Suppose I am taking a BC triangle, and this is This is MNO triangle. Okay, here side AB is let's say 18 centimeter. This is BC is let's say 12 centimeter, and AC is let's say 24 centimeter. Okay, here I am taking side MN as 6 centimeter, MO as 8 centimeter, and NO as this side NO as 4 centimeter. Then can we say these two triangles are similar? Can we? So the first criteria, each and every angle has to be same. So I see angle A over here is equals to angle B over here is equals to angle N over there. Perfect. I can see angle C over here is equals to angle M over there. So there are three angles which are just equal with each other. Okay, angle we got it. Now there is one more criteria, that side also has to be same in proportion, not same, in proportion. What is the meaning of proportion? Proportion means the ratio between the side must come out as the same. Let's check it. Let's check it. Suppose I have taken AB over here, AB by, let's say I am taking MN 18 by 6. 6 1 times 6, 3 times 18. Okay. Other one I am taking BC by NO, that is 12 by 4. Can you see 3 by 1? Similarly, I am taking the third side, that is AC by MN, not MN, AC by the third side MO. AC is 24, MO is 8. Can you see we are getting the side, all the ratio between the sides are same, 3 by 1, 3 by 1, 3 by 1. If that is the case, sides are in proportion with each other, then we will say that yes, these two shapes are similar shape. Have you understood the concept of similar shape? Alvina, Noah, Afnan, are you understanding what exactly is the meaning of similar shapes?
Yes, ma'am.
Okay, this is what is the meaning of similarity. This type of question we are having over here, not for now. Okay, in the second exercise we will be solving this type of question, but not for now. Okay, we just need to understand the meaning of similar shapes. Okay, what is the meaning of similar shape? One can be bigger, another can be smaller. We are going to call it similar, but we will be careful these two criteria is getting fulfilled or not. That's why we say that all the squares are similar, like all the square, a bigger square, a smaller square, like a smaller square, the medium size square, and the again the bigger square, like this two, the first two, the second two, the first two, the second two, these all the squares are similar. Why we are saying? Because in a square there is only one measurement. There is only one measurement. If this side is 5 centimeter, another is also 5 centimeter, another is also 5 centimeter, another is also 5 centimeter. And whatever be the size of this teeny tiny square, be it 2 centimeter, 2 centimeter, 2 centimeter, and 2 centimeter. Can you see that all the side will be in proportion? Can you see? Can you see?
Yes, ma'am.
5 by 2, 5 by 2, 5 by 2, 5 by 2. Every time side will be in proportion. So when we are talking about a square, always the side will be in proportion, and each and every angle will also be same, since we are talking about a square only. So internal angle will be 90 degree, 90 degree, 90 degree, 90 degree. So yes, these two shapes are same. So whatever two square you are going to take, since a square is having just one measurement, that means all the sides are same. Eventually you will find that sides are coming in proportion only. And same goes for the circle also. In circle, there is only radius. So whatever two circle you will draw, anyway you are going to draw two circle, one bigger one very smaller, or one the average one, the medium size one, then again very smaller, or one very huge, and then one, any two circle you are going to draw by taking any two measurement. Be it you are drawing two circle, you are drawing one of the circle by taking 8 centimeter measurement, and you are drawing another circle by taking 3 centimeter. Can you see the radius is in proportion, like 8 by 3 only we are getting. No need to compare the other thing. Okay, angle will be same, because in a circle complete 360 degrees there. So obviously that goes for any circle, that goes for this teeny tiny circle also. The complete angle will be 360 degree. That's why we say that all the circles are similar, all the squares are similar figure. Okay, all circles are similar, all squares are also similar, and all equilateral triangle are also similar, because here we are having in these three cases always the side will come out in proportion only. Equilateral triangle are in proportion, no, similar we are going to write. It will always come out in proportion. Okay, but for other shapes, rectangle, quadrilateral, we have to check. So let's take one figure. Now you must have heard about a real life scenario. Passport size photo, the stamp size photo. Okay, so these are the picture which the whoever is going to just the photographer will just reduce the size of the photo, but everything they will reduce in proportion. By maintaining the proportion they will reduce. They are not going to reduce like one corresponding side in this ratio, another in another ratio. No, they will maintain the proper ratio to give us any size of picture. Sometimes we give passport size picture and we say that just make the picture of all the sizes, and they give also. So what they do, they just enlarge in ratio, they just squeeze in ratio. Okay, they just make it compact in ratio by maintaining a proper proportion. They do it. Okay, and that's when whatever picture you are getting, the collection of stamp size, passport size, so all are similar shapes. One can be bigger, another can be smaller, but that are in proportion with each other. Randomly it is not bigger or smaller. Okay, all the sides are in proportion with each other. All the measurement, rather I would say all the measurement are in proportion with each other. That's the meaning of similar shapes. Now one figure is like this. D, C, A, B, this is 85 degree, this is 70 degree, this is 2.4 centimeter, this is 2.5 centimeter, this is 100 centimeter, 100 degree, and here we are having 1.5 centimeter, here we are having 2.1 centimeter, and this is 105 degree. Okay, here we are having S, here we are having R, we are having Q, and we are having P. Okay, this is 85 degree, 70 degree, 105, 100. 4.8 centimeter, 5 centimeter. You have to check which sides are in proportion with, like, which two sides are in proportion with each other. That you have to check. Randomly you will be taking and you will be getting that all sides are in proportion. No, it's not like that. You have to check, you have to observe the figure very carefully. Now you tell me whether these two figures are similar or not. Analyze it carefully and let me know whether these two figures are similar or not.
Yes, they're similar.
And if you divide them by 2, they'll become similar.
Okay, Afnan said it's similar. Alvina, you are also saying it's similar, right?
Yes, ma'am.
Who? Anyone else?
I also said it's similar.
Okay, so Maya said it's similar. Noah, is it similar?
Yes, ma'am.
Let's check that. What I said, all the angles has to be same and sides has to be in proportion with each other. So this is 70. Is there any 70? Yeah. This is 85. Is there any 85? Yeah. 105 is there. 105. 100 is there. 100 is there. Yeah. Perfect. Now 2.4 centimeter is there, and there we are having 4.8 centimeter. So you can see that's all the sides are just half. Like what I'm saying, the proportion has to be same. That means if you are cutting side CD in, like side CD and SR, if you will compare, you can see that 2.4 into 2 is 4.8, or maybe you can take it this way, SR is 4.8, that divided by 2 is 2.4. And if this is how it is not clear, then find the ratio. Then let's find the ratio. If this is how it is not clear, find SR, the bigger side, by the smaller side, CD. 4.8 by 2.4. Okay, find like this. Remove the decimal, it will become just 48 by 24. Do the calculation. Do the just cancel it out. Tell me what are you getting? 12 2 times 24, 12 4 times 48. What are you getting?
4 by 2.
1 by 2 by 1, right? Similarly, you will find that all the sides BC by QR. Be careful, here you have taken the bigger quadrilateral side, and then you have taken the smaller quadrilateral side. So in this manner, we are going to take all the other ratio also. The bigger side by the smaller side, this is how we are going to take. Otherwise, here and there you will do. First, you will be taking the smaller one, then the bigger one. See, RS is from bigger shape. Can you see the bigger shape we have taken? By CD, I have taken from the smaller shape. This sequence you have to maintain. Okay, now we can take QR by BC. You will find that again you got 2 by 1. Okay, now we will be taking again the bigger one, that is PQ by AB. So if you are writing the bigger quadrilaterals side in the numerator, in all the ratio you have to write the bigger quadrilateral sides in the numerators part. Getting it?
Yes, ma'am.
Every time, then and only then you will be getting 2 by 1. Otherwise, one time you will end up getting 1 by 2, and you will say that all the ratio are not same, which is not the case. So when you are taking the sides in proportion, either take the smaller one first in the numerator and then bigger one in the denominator, or take bigger one in the numerator, smaller in the denominator for all the cases. For all the cases, then only you will find that the sides are coming in proportion. Okay, for Arya only I started this chapter and she is only not there. I wanted to discuss a theorem which is there. Just a moment. Before starting that theorem, please let me know. When like I have discussed with you all, still I want to ask you, like when you are having your upcoming exam, is it over or it is going to happen in near future? Please let me know.
Mine is on 28th May.
28 May and Afnan, all the chapter we have already covered, right?
And trigonometry is left. 2 chapters are there.
Trigonometry is there. You have not informed me that we need to take trigonometry.
Am I informed?
So why we are discussing triangle then? We must have started trigonometry. Now only it is 22. Already it is. From 28 you are having Afnan.
Yes, ma'am.
Okay. Yes, rest of the student. Alvina.
Ma'am, my exam is starting from 2nd of June.
And
It is my
what
first exam.
chapters are going to be there?
Chapter 1 and 2, real numbers and polynomials.
Okay, we are done with that. Noah.
Teacher, we have real numbers and probability.
Probabilities we have done, right? It is there in your exam, right?
Yes, ma'am.
Okay. Afnan, just a moment. No, let me inform our team that you are having trigonometry.
Ma'am,
Yeah.
you have not finished polynomials.
Polynomial. Okay, I have not finished.
No, ma'am.
Huh?
Yeah,
Till where I have discussed. Can you let me know?
um,
Graphical part, how to check from the graph which one is the zero, which one is not the zero. Have we done? Alvina,
yes, ma'am.
the graphs have we done? To check from the graph, we have to say how many zeros are there. That concept we have discussed together. Yes or no?
Yes.
Okay, the relationship between zeros and the coefficient we have discussed, that is alpha plus sum of the root is this one, product of the root is this one. Have we done?
Yeah.
Then what we have not done? Only these two concepts are there. The relationship between, okay, the last part we have not done. That is when the sum and the product of the zero is given, then how to frame the equation, that we have not done.
Yeah.
Okay, let me show you on the screen. Tell me whether this one you know or not. If sum of the root, if sum of the roots of a polynomial, Afnan, I am informing my team, operation team, to arrange a class for you. Okay. If sum of the roots of a polynomial is 5 and product of the root then find the polynomial. Yes. Can you tell me how to find the polynomial? Alvina. Alvina, what will be the polynomial? Have you seen this formula, Alvina? X square minus sum of the roots into x plus product of the roots. Have you seen this formula, Alvina?
Ma'am, I saw a formula similar to that in under quadratic polynomial, that x square minus alpha plus beta x plus alpha beta.
Yeah, it's that only. So